Hi everyone. In this given problem statement of word ladder, our transformation sequence from an begin word to an end word using the dictionary of word list in a sequence. So here we have to find the minimum or the shortest transformation sequence from begin word to the end word. And whatever transformation steps that we're going to take, right, it should be present in the word list. So to solve this type of problem, we have to use graph and BFS breadth first search. So let us take this example of hit, right? So what are the transformations that are possible? So it can transform to any word like from A to Z. Okay. So H can transform to D or whatever, right? So it can transform to a lot of options. So it can transform to A to Z. I can transform to A to Z. T can transform to A to Z words. In this case, right, if I look into the sequence, the shortest one, right, is that I get transformed to O. So it would become HOT, and all the other transformations, it once the transformation is done, right, we are going to check whether that value is present in the word dictionary. In that case it won't be, so we are not going to consider that. Now from HOT, it can again, H can transform to A to Z, O can transform to A to Z, and A to Z. So here, right, what we can do, H gets transformed to D O T. So this H value is getting transformed. Then DOT, right, can transform again. T can transform to A to Z, A to Z, and A to Z. And whatever values or steps you're going in, right, we are going to add it to a visited set so that we do not repeat this step again. So from D, right, it can go to DOG. So it got transformed to A to Z. So dog. And at last, right, our end word is COG. So it can again transform to A to Z, A to Z, and A to Z. So in the transformation, I'm going to find COG out here. So this got transformed. So here, right, number of steps that is going to happen: 1, 2, 3, 4, and 5. So there will be 5 steps to get transformed from hit to cog. So it is going to be 5 transformation steps, and that would be the minimum transformation that is required. So here, right, one thing we can do, because it's a smaller number of words, so instead of transforming all the characters to A to Z, right, we can basically take the set of all these values. So we can join all these values and take a set. So the unique characters would be, and so that same value does not get repeated. So if I do a set, right, it would be something HOED L G C. So this would be few characters instead of going 26 times, right? Better to take a set of all the possible words that are present in the word list. So that is going to improve your total number of steps. And here, right, if I look into it, right, it's going to be go of n, because whatever steps that we're going to take in, right, it needs to be present in the word list. So using an BFS and a DQ, right, we can easily solve this problem. So now let us jump to the Python solution. So the first thing we are going to do, right, we are going to take the length of our current begin word. So length of begin word Now I can also need to take the mutations that are possible. Mutation or the transformation, right? You can do it as you want. So first thing that I can do, right, I can join all the words. So join word list, it is going to give me a string value, and then I can take this set out of it, and at last I can do a list transformation so that I only have the unique characters. Now I can have my DQ. So for DQ I have to import DQ. So from collections import DQ. Once that is done, I can say Q equal to QUE, and here I can say Q dot append, and the initial word is going to be begin word, and the number of moves it is going to take me, it's going to be 0. Once that is done, right, I'm going to loop it while there are values present in the queue. So I can say word and moves equal to q dot pop left. Once that is done, for I in range 0 to n, so all the word indices, right, we need to change it. But here one more thing, because it's a string, right, it is not mutable, so I have to change it to a mutable list. So I can say word list equal to list of word, and then I'm going to loop. So for m in mutation word list of I equal to m. Once that is done, I can basically convert it back to strings. It would be dot join word list. Now if word str, yeah, I also have to create a visited set. Is very important. VISI visited, to keep a track so it do not repeat the same steps again and it does not go into a cycle. So if word str not in visited and word str in word list, in that case I can say visited dot add word str, at the same time q dot append word str comma moves plus 1. And here I can do one more thing, which is basically if the current word is equal to the end word, then I can return the number of moves. So that's pretty much the problem. And in case if it's not able to resolve it and while loop exists, then we can say there are no way we can go from the begin word to the end word. So in that case I can return -1. Let me run the problem. I think it should work. Let's see. it is throwing an error. So we are getting some errors. So how to solve it? So one thing that we can do, right? Instead here, right, we are getting an error. So if I look into the errors, right, it is throwing an output 4 and also here it is -1. So if I look into it, right, here instead of q.append begin word to be 0, I have to send it as 1. And here, right, it's been written, right, you have to return 0 in case no such sequence exists. So instead of -1, I have to return 0 out here. So if I run this, it should work. So as you could see, the test cases passed. Let me submit the code. And here most probably it is going to give me an timeout exception. So time limit exceeded error. So the reason why it is happening, right, when you are searching if word not in word list, right, it is an linear search. So it is big O of n. So instead of doing that, right, can I search it in just one, so big O of 1. So I can do it using set. So word list, just this much. If I do it and if I run it, right, it's kind of a trick. It should give me the solution. So let me submit it back again. As you could see, it ran successfully and it is beating 54.65% of the submission. So it's a pretty efficient solution. That's all for this video. See you in the next one.